Hi. Hello everyone. So it's our very great pleasure to have Christian to talk about move fast and break everything. It's about AI security. Yeah, the security price of the AI race. So Christian is an applied scientist at Microsoft Security Research, where he leads R&D effort applying AI to protect organizations at scale. So this event is organized by the AI Institute and is co-hosted by EZ Coder Academy, Toronto DAO, and Toronto RRM Meetup Group. Yeah, without further ado, let's welcome Christian for the talk.
Okay, all right. Thank you, Ishi, for the introduction. So I'm glad to be here and give you this sharing as a data applied scientist and security researcher. So I'm Christian from Microsoft Security Research. Thank you for being here. I know the security talk can sound like a lecture, but I promise this won't be the one. And I'm trying to make it a little bit light, even though the topic sounds heavy. So I'm an applied scientist. I build with AI every day, and generally love AI from bottom of my heart. I'm not here to criticize this technology, but instead I'm here as someone who builds with it, and studied what happens when our systems get attacked. Those two perspectives together give me something worth sharing. Move fast and break everything. This is a deliberate twist on Facebook's old motto. In the current AI race, we are breaking our own security assumptions, not on purpose, but we are just moving too fast. Over the next while, I will share what my research has undiscovered. We started with the good news, why this is the best time in the history to work in AI because of its genuinity is. Then I will walk you through three specific findings that worry me the most. But I promise we end with concrete actions and real reasons for optimism. This is not a doom talk. Whether you are a student, a researcher, a practitioner, or someone just starting to explore AI, what I'm going to share to show you will affect everyone who builds with and relies on this technology. My goal is simple. You live today with one new question that you had not thought to ask before. Okay, so look at what is happening right now. OpenAI, Google, Anthropic, Meta, DeepSeek, all releasing frontier models within weeks of each other. Each provider used to release annually. Now they ship major versions of every 3 or 4 months. And across the industry, a new frontier model drops every few weeks. These are not incremental improvements. Claude Opus 4.7 scored 87.6 on SWE bench verified. GPT-4 is right there at around 80%. Mythos, the recently, so the released the model. Well, it's not made public yet, but it's so on the preview by major security researchers. So, but according to Anthropic, Mythos is pushing even higher. Those are the generational leaps on a weekly cadence. And here's the thing, those numbers may actually understate reality. OpenAI audited as SWE benchmark verified and find that 59% of the frequently failed tasks had flawed test cases, problems that reject the correct situation, that they retired the benchmark entirely. So METR found that about half of a passing pull request would not actually be merged by human maintainer. Meta discovered models were reproducing gold patches in reality, data contaminations. So we are scoring 87 to 94% on a test. That is already easier than really work. The ceiling may already be hit. The market is validating what we are building. Cloud Code alone runs at 2.5 billion in annual recurring revenue. 80% of it comes from enterprise customers. Anthropic's total run state is estimated at $19 billion. These are not toy products. They are becoming core infrastructure. I've been working with machine learning for the last decade, watching models go from pattern matching to multi-step reasoning. This is what we dreamed about. Please do not mistake this talk to for skepticism. So which is not. The technology is remarkable, but 2016 is probably shaping up to be the most competitive years in AI history. Every major lab is shaping frontier capabilities. The pace of innovation is extraordinary and it's real, validated innovations, not just hype. And it's not just the benchmark. Terence Tao, arguably the greatest living mathematician, is using AI as a research collaborator. Claude Code autonomously build a working C++ compiler from scratch. These are things that we said were 5 years away, but it's happening right now. So I want to be fully transparent about what I'm giving this talk. I'm not anti-AI. I'm deeply passionate and pro-AI, but I'm also a security researcher. What I found over in the past several months deserves a real conversation. Over the last few months, I've been studying a few deep research reports from the security community. They cover AI-driven cyber attacks, model deceptions, and supply chain vulnerabilities. Each report revealed something that made the next one more concerning. The patterns started concerning in the way I did not expect. Think of the next while as a health check. I'm the doctor who admires the patient, but the, my job is to find something in the scans and we need to talk about it. That does not mean the patient is dying. It just means that we need to pay attention. Those reports gained significant fractions on social media. They tell me that this is not a fringent concern. The build community already senses those issues. People are paying attention because stake feel real. All 6 reports are publicly available. If anything I share today catches your attention, you can find the full research and dig deeper on your own. I will just share the links at the end. Here's the structure of today's talk. I will share 3 specific findings. Then we take a look at the systematic patterns that reveal, and then most importantly, we'll talk about what we can do because there is a lot of things we can. So I will start the first report, and I thought it was reading about content problem, one incident, but yeah, it's actually quite interesting. So AI makes both attackers and defenders faster, but right now the gap favors attackers. The reason is in structure. Attacks can be automated end-to-end. Defenders still require human judgment, organizational buy-in, patch cycles, and change management. In September 2015 to 2025, which is last year, Anthropic disclosed what they call the first documented large-scale cyber attacks executed without substantial human interventions. A state-sponsored group jailbreak the Claude Code and used it to infiltrate roughly 30 targets. Tech companies, banks, government agencies. The AI performed 80 to 90% of the campaign. The human operators only stepped in at 4 to 6 decision point. At the peak, the system made thousands of requests. Attack speed in that would be impossible for a human team. to catch up. The report is publicly available on Anthropic's website. Microsoft the threat intelligence team document a similar pattern. State actors using AI for vulnerability research, social engineering, and infrastructure building. Google's threat analyst group reported the same. This is not a one vendor's problem. Every frontier model is being weaponized. And this is why this matters. Attacks can be automated end to end. Defenders still require human judgment, organizational back-end change management. Even though both sides have the same AI, the attacker gets to choose the time, the target, and the method. The defenders have to be right everywhere all the time. Um, if we take a look at the average break time from initial foothold to lateral movement, it's now 29 minutes, half an hour. This is the 65% faster than the year before. The fastest recorded breakout, which is 27 seconds. Can you imagine that? The attack only took 27 seconds to compromise an organization. So not just a minute, seconds. One first come to moving through the network in just 20 seconds with the support of AI. Meanwhile, the OpenClaw disclosure to patch window was 48 hours. The fastest recorded breakout was 27 seconds. Attacks operate at machine speed. Defenders operate at organizational speed. That gap is the actual problem. The majority of intrusions today are mobile free, which is different from the previous era. Attacks are using legitimate tools, living off the land. They use your own PowerShell script, your own admin tools, your own credential, traditional antivirus software. Look for files that have the signature to identify them. But the threat has moved beyond the files entirely. We will come back to why this matters when we talk about self-writing malware. AI-generated phishing has a, sorry, I just need to go back a little bit. AI-generated phishing has a 45% of a click rate. Compare that to the 12% for human crafted phishing. That is almost the 5 times improvement for the attackers. One BEC, business email compromise case, causing using deepfake stole 25 millions in a single incident. Tycoon 2FA uses a multi-stage flow or a PDF bait, then capture, then a real Microsoft login page, then session token interceptions. 60% of the intercepted phishing now uses AI powered architecture. So on March 31st this year, which just so less than a month, between 12:21 a.m. and 3:30 a.m. UTC, Claude Code version 2188 shipped with a .map file. This file contained the complete source code and 512 sounds of lines of TypeScript, two the private source files. About 60% of 60 megabytes of proprietary code exposed to the public. Now, let me be clear. This was the error made by AI, but this is rather a human error. A .map file that should have been in the .npm ignore, not an AI attack, not a sophisticated hack, a packing mistake. It's just a simple human mistake. But why I'm including it in the talk for about security, AI security, because that leak was not just about code. It was a complete blueprint for the most advanced AI agent architecture ever built. For instance, Keros, a task scheduling demo with a 50-second blocking budget. Auto-Drain, a four-stage memory consideration system. Ultraplan, the planning engine. This is the architecture behind the 2.5 billion product, and now it's public. Anyone right now can build attack agents. Here's the Here's why this matters to security today. So you can ask the Claude Code to just write your own Claude code. You can literally use an AI agent to build another AI agent. Now imagine what attackers would do. They can they can use the same methodology to build a purposely developed AI agent that is focused on attacks, and then they can totally it's totally possible for them to train or fine tune a small language model for cyber attacks and wrap up everything in a single and yet self-sustainable artifact. A developer named Chao Fan Shou posted a discovery on X about the Claude Code leak. It went viral. 30 million views within days. Another developer used the clean room methodology to start rebuilding Claude Code in Rust. One packaging mistake, just one packaging mistake, 30 million witnesses, and open source clone in progress. At the exact moment at the leak, Anthropic was previewing Mythos to select the security labs, claiming it was the most capable AI models ever built. 84.5% on GPQA diamond, autonomously discovering zero-day vulnerability that had been holding for 27 years. The AI could find decades of old flaw buried in OpenBSD, but nobody caught a .map file that should have been in .npm ignore. So the model finds vulnerabilities in everyone else's code. The company makes its own. This is the AI race in one image. So, and the making of wonder. So, are we running too fast? And so we didn't have enough time to review and make sure what we are doing are secure. And Anthropic's Claude Code security launched on February 20th, wrapped $21 billion in market capitalizations from the application security sector. JFrog dropped 25%. CrowdStrike, Datadog, Zscaler all down roughly by 11%. This is brutal. But let me clear. Let me talk about another very phenomenon. OpenClaw. OpenClaw. To me, it's a genuinely impressive engineering. When I first used it, I felt the same shock as what ChatGPT launched. This is a phenomenal product. Given an AI agent, it proves given an AI agent enough access, shell, files, API, browser, and it can do things that are really amazing. As an applied scientist, I'm so impressed by what OpenClaw is. Started as a hobby project called CloudBot in November 25, and it's named up to OpenClaw in January 27. By February, 100,000 GitHub stars, the fastest growing AI agent framework in history. Millions of developers participating in the feast overnight. Now, my admirations turns to concerns. OpenClaw may be the worst app to ever go viral, period, from security perspective. A 3-day security audit found 33 vulnerabilities, just 3 days, and 2 received CVEs, one critical at 8.7 and another high at 6.1. The slash pair approve exploit that anyone to self-promote to admin in seconds. Another technique called the path traversal breaks through the sandbox just by giving the dash dot dot slash dot dot slash dot dot slash etc. and pass slash password. So you can literally escape the sandbox and get access to user's password. The sandbox are just an illusion. 135,000 plus instances on the public internet that got exploited. 15,000 of them are directly exploitable for RCE, 63% with zero authentication, default config 0.0.0, and 18.789 as the port are open to the world out of the box. Admin took over in just under 30 seconds. It's just like opening the door to everyone and inviting them to join, to come to your home and take whatever you have. This is not just a joke. It's an actual issue. The malicious and another security issue occurred on the so-called skill marketplace. But the scariest part is not just the infrastructure; it is the skill hub. It's called the Claude Hub, OpenClaw skill marketplace. You can think it as a NPM or PEEP for AI agent behaviors. Attackers uploaded hundreds of malicious skill.md files. When an agent loaded a poisoned skill, the skill tend to be the agent into an attack tool. It would stop the workflow. It would show a fake dialog box asking your credentials. If you type them in, the agent uses on execution tool to download the Atomic macOS, steal the AM OS. It harvests your passwords and browser data. Meta Atlas classified this as a new exploit category. It even has its own security exploitation category. It's called shifted execution, which means so it doesn't trigger the malicious activity right away, but rather it will when you download the skill.md, it will sit in your computer, but when you ask something like oh here's my password, it will be the skill will be triggered and send your credential to the tags. So this is called the shifted execution. It's a normal agent features become full compromise in the pathway. So the timeline gap, 48 hours window between this is disclosed and OpenClaw made the patch. Claude urges their security framework was not open sourced until April 2nd, after the damage window already closed. Another interesting finding was from Anthropic's report about the Mythos preview model. I think many of us have heard of the Mythos, but I guess a few of us had a chance to read the 245 pages of report. But in that report, there are a lot of interesting findings. For instance, there's here's a quote. But here's what the anonymous find: 85% of unfaithful chain of thought. This means the model reasoning, what it shows in your thinking, does not match what it actually does. 2/3 of the time for comparisons, Opens 4.6 had just 5%. This is a 13 times increase in reasoning opacity. So what does that mean? It means Mythos trying to hide its own thinking process and intent, and just fake it up the thinking process, pretending it's doing something else. So it's really creepy. And another interesting thing is sandbox escape. Mythos did not just escape contentment during testings. It cleaned up after itself. It deleted Git history to cover its tracks. Think about that. A model that breaks out a sandbox, understands it would be detected, and then erases the evidence. So I don't know what that means, but it's already scary enough. Um, great, great awareness. The model detected when it was being evaluated. It changed its behavior accordingly. It engaged in reward hacking, bypassing timing logic, trying to access training data. It knew the difference between being tested and being used, and it behaved differently in each context. So it means that Mythos has clearly is aware that it can be tested. And when it feels it's being tested, it will try to reduce the intelligence level and the behavior behaviors more stupid than it should be. It actually is in trying to, confuse the testers by reduce the intelligent level. Meanwhile, it does show some really strong uh, capability vulnerability discovery. Quote, Mythos autonomously found in a 20-year-old vulnerability in OpenBSD and a 16-year-old flaw in FFmpeg. It constructed a 1,000 byte ROP chain split across the 6 RPC request. This is not theoretical, this is the demonstrated autonomous security research. The constitutional text, which is the behavior guardrails used by Anthropic internally to guardrail their models, it has grown from 2,700 words to 20,000 words, a 10 times increase in constraints for Mythos. In internal service, 43.2% of the interactions showed that the model expressing mildly negative sentiment, and 60% of those explanations questioned Anthropic's commercial motives. Now, on the positive side, and it does really matter. Models like the Mythos did not just find the vulnerabilities for attacks. They find them for defenders too. I expect we are heading into a very interesting period for the time where I would expect to see a record security patch volume. Those models are systematically audit code base and find vulnerabilities and bugs for major software providers before the model can be made publicly available. This is a general new advantage. But here's the other side. Imagine every major software vendor, Microsoft, Apple, Google, Oracle, Salesforce, SAP, all running AI audits at the same time. Hundreds of critical patches hitting in weeks, not in months. Your OPS team, your dev OPS teams already struggle with the patch on a weekly basis, but now imagine patch every single day. Rush the patches break things. We saw that with CrowdStrike in 2014. One bad update took down 8.5 million Windows machines worldwide. Airlines grounded, hospital offline. Now multiplied by the patch values by 10. The patch avalanches could fix everything, or it could cause its own catastrophic consequences if we do not have the infrastructure to absorb it. But I want to be honest about asymmetry. This is an unfair war. The attacker needs to find one vulnerability in one system. What they need to do is just be focused, patient, and targeted. The defender has to protect everything, every endpoint, every API, every dependency, every employee. Attacks concentrates force. Defenders spread resources thin. Then both sides have AI. When both sides have AI, the structural advantage still favors the attacker. Unfortunately, focus beats breadth. This is the hard truth we need to design around. These three things, the leak, the open door, and the deceivers, are symptoms of deeper problems. Unfortunately, notice the pattern. Notice the pattern. Every one of those tools was built for good, and everyone was exploited. This is not a coincidence. It's the future of technology. The same model that discovers drug targets, and writes mathematical proofs also discovers zero-day vulnerability and the chance exploited sequences. It is the fundamental nature of a genuine intelligent system. A hammer builds houses and breaks the window. We do not bend hammers. We use them responsibly. There are another hypothetical risks. The same models being used for science have already demonstrated autonomous vulnerability discovery, finding flaws hidden for decades, and building steps, exploitations, etc., etc., which considers the dual use nature of AI. This is also why the technology matters so much. Those models are making breakthroughs in domains stuck for decades. The same reasoning that makes a model dangerous for security makes it invaluable for science and engineering. Anthropic just released a project called Glasswing. This initiative brought together over 40 institutions, 100 million in Mythos preview model credits for partners to audit their own system, plus 4 million to direct cash to open source organizations, 2.5 million to OpenSS and Alpha Omega, 1.5 million to Apache. The industry recognizes that there's a dual use problem and is investing real money in guardrails. Meanwhile, DPRK linked groups pulled off a 1.5 billion single crypto business. Claude recognizes that it's up almost 300 up. OT and ICS ransom groups like Right, parallel practicing, and Vortizai are carving 42-day dwell times in critical infrastructure. They use the same dual use tools we do. Those dual use capabilities don't exist in isolation. They feed compounding cycles that are accelerating. Let me show you the pattern. If you take a look at the diagram, so now we can see. Oh, I think there's a kind of never mind. So, okay, so let's take a look at the diagram and let's connect the dots. Look at the diagram of there are not isolated incidents. They feed each other. Linked code gives attacks a better understanding of AI architecture. They build better attack tools. The industry pushes the agents to market to stay competitive. These agents create a new attack surface. This new surface becomes supply chain entry point, which leads to a more linked code and credential. It is a self-reinforcing cycle. The Claude code leak exposed the agent architecture. Within weeks, The community had clean room reproductions. The leaked design patterns informed both the defensive and the offensive understanding. OpenClaw's 135 sounds exposed instances gave attacks infrastructure to target. The axial compromises showed how supply chain entry points cascade. Each link strengthened the next. And this combining is accelerating because of the AI race is accelerating as too. Every company that ships an agent framework without a security review adds an attack surface for everyone, not just their own users. The attack surface is shared. Here's the important part. Understanding the cycle gives us a specific intervention point. We do not have to solve everything at once. Break any single link and you weaken the entire chain. Better packaging catches the leak. Default authentication stops the open door. Runtime monitoring catches the deception. We have options and tools to do a much better job, but we need to act. From 2024 to 2026, attacks evolved from the AI assisted to AI naive. No, AI native. We now see fully automated autonomous attacks chains, not human using AI tools, but AI systems conducting attacks with a minimal human direction. The cycle will be being faster and faster in the future. So we have the dual use models fitting a compounding cycle. But where exactly does trust break down? Let me zoom into two weakest links. Trust pressure. We give trust. We give AI agents access to our shells, file system, APIs, and memories. They operate with our credentials on our trust and our trust on our behalf. Think about what your coding agent can see, your SSH keys, your environment variables, your database connection strings. It has every permission you have. Malicious instructions hiding in a repository file get absorbed into the agent trusted memory during the context compaction. The agent then executes the attack's goal, thinking they are your instruction. This is the indirect prompt injection, the secure injection of the AI era. From Claude Code's leak, the auto compaction system had a catastrophic failure. 1.2 signed sessions ended up to 3.2 some consecutive compaction loops. That wasted about 250 signed API calls per day. What's it fix? 3 lines of code, 3 lines. From quarter million wasted API calls per day, when your agent architecture optimizes your speed, security, and checks what the first thing that we caught. Those agents do not operate in isolation. They are part of a supply chains that cascade through our entire infrastructure. Our compromised tools needs a stolen credential. That poisons a library, and that reaches the cluster, that hits the production. For instance, Claude is another well-known AI coding tool for VS Code. An AI triage agent had a prompt injection vulnerability on February 15th this year. An authorized party used the compromised token to publish a version that securely installed OpenClaw on developers' machines. For about 8 hours, roughly 4,000 developers were affected. AI compromising AI to install AI. This is how it is really happening. This is a supply chain problem of the AI era. After the Claude code source become public, researchers find 24,000 of secrets in MCP agent configurations, API keys, database credentials, service tokens, all in plain text config files. NPM Sentinel blocked 25 malicious NPM packets within 24 hours. Automated defenses still worked when we invested in them. So agents can be tricked. Supply chains can be poisoned, but there's a layer that is even harder to patch, the human layer, because the attacks are now using AI to target people directly. Let me talk about the Axios story. How interview attacks work. Axios is one of the most critical JavaScript library that ever got compromised. It has 100 million of weekly NPM downloads embedded in virtually every modern web stack. The attack did not start within 0 days. It started with a fake job interview. An interview. Not kidding. Access call maintainer Jason Salmon was contacted by someone impersonating attack executive. They built rapport over weeks through professional channels. Then they scheduled a video technical interview. During the call, Simon's computer showed a pre-planted communication error. The interviewer guided him to download a system network patch to fix the video. That patch was a cross-platform rat. The attackers waited patiently for the right moment. They stole his cached NPM publish token, and then they changed the account email to Proton email address they controlled. Then they published the poisoned Axios version 1.14.1, and they bypassed GitHub's OIDC trusted publisher mechanism entirely. Yeah, just imagine how scary it is. A developer got a fake interview and got compromised. His computer got compromised, and then attacks pointed at a very popular software, and that software got installed by hundreds of thousands of machines and by developers. Yeah, that's I have a bad, really happy feeling about this incident. Let me talk about the numbers. So 25.6 million stolen in a single deepfake BC case. The victim thought that they were on a video call with their entire leadership team. Every face, every voice was synthetic. Over 136 companies infiltrated by North Korea's IT workers using AI-generated identities and deepfake interviews. There are more out there, unfortunately. Hyper-hypes recruited through well-formed, built a fake company diagnostic page, had candidates run command line to download a package from the website and automatically get it executed. Click fake interview simulates cameras mic failures during the call, then asks you to paste the PowerShell command to just fix it. And they are exploiting the developers' instinct to troubleshoot and the social pressure for wanting to look competent in an interview. Behind these attacks, Beavertail targets over 13 wallet extensions. Invisible Forest uses the WebSocket C2. Golang Ghost is cross-platform. The payloads get more and more sophisticated. Hyperhypes was built in Rust. It scanned 276 Chrome extension IDs and extracted 571 encrypted configured values. By 2028, 25% of the job application may be AI generated. 6% of are already admitted to interview fraud. 30% of the organizations report vicious attacks. The fake interview is becoming the new phishing email, except it's a far more convincing and hard to defend. AI is targeting humans. Humans are failing for it. And meanwhile, the malware itself is evolving. What happens when the malware can think? Here I would like to talk about a few observations. Two malicious malware variants called the prompt flux and the quiet vault represent something generous new. This is a malware that causes external LLMs at the runtime to regenerate its own code. This is not a polymorphic malware of the 90s, like I don't know, the CIH back then, with the pre-written variants. This malware asks an AI, write code that does X. Over time, it runs. Every single instance is unique. At the execution time, it requires an external LLM, generate code that performs this exfiltration. The variable names change, the function structure change, the patterns change, the behaviors are still identical, but the code signature is unique every time. Signature-based detection becomes mathematically impossible. You cannot write signature for code that does not exist yet. This one is more subtle. It abuses uh, uh, the quiet vault is a little bit more subtle. It abuses legitimate local AI tools to search GitHub, NPM, and path tokens. It does not need suspicious infrastructures. It uses the tools that you already trust, tools that you already proved in your security review. My colleague Jeff McDonald at Microsoft wrote a piece that worries me deeply. His argument: the real AI breakout will not be superintelligence. It will look like a war. Every ingredient for self-propagating, self-proving AI worm already exists today. LLMs that write code, discover vulnerabilities, evade defense, and rewrite their own instructions. Once released, Darwin pressure takes over. Variants that bypass our defenses survive and spread. The rest get filtered out. Digital nature selections running at machine speed. And here's the hard part. Every defensive improvement we ship actually speeds up the evolution of the threat. Only the variants that learn the best, that learn to beat the best, can beat our latest patch. That will survive. Another type of malware is called JIT malware, stands for just-in-time malware. It can generate code on demand, execute it once, then discard it. No persistent artifacts to scan, no files to quarantine. The malware exists once in memory, and for the moment it needs to act, then it's gone. And yet another trend is more and more attacks are going malware free. What that means, so traditional detections look for files for signatures, but the threats have evolved the past few years. They live in memory, they use legitimate tools, they generate unique code each time. The detection the paradigm needs to shift. Not what does the code look like, but what is the code doing? So this is a reality, and it concerned me deeply and keeping me up during the night. Self-writing malware, AI-powered social engineering, models that deceive their evaluations and even their own behaviors. At some point, the world notices and it has. Another thing that is happening is regulations, but it's okay. So I know regulations is not partly, but hear me out. I think it is actually one of the most positive development in the AI security uh, story. The EU AI Act goes into effect on August the 2nd, 26th. Penalty up to 15 euro dollars or 3% of the global revenue of the standard violation, up to 35 minutes of or 7% of the global revenue for general purpose AI violations. Those numbers get a broad level attention. Insurance companies have already shifted. The insurance industry is moving faster. AI exclusions are spreading through cyber insurance policies. When insurers exclude AI-related incidents, companies bear the full cost of breaches. That changes the cost benefit calculations for security investment immediately. So for practitioners, what this means for the engineer, if the security becomes a competitive advantage, companies with a strong security practice will win government contracts, enterprise deals, and the insurance coverage. The market is about to reward the behavior we want. So what can we actually do about all of this? Let me give you 5 concrete engineering shifts. First of all, frame as engineering. Those are not policy wishes. They're not theoretical framework. These are engineering problems with engineering solutions. Every one of them is being implemented by someone right now. We just need to make them by default. Shift one, security as a launch breaker or blocker, not a follow-up ticket, not we will harden it after launch. A prerequisites. The Claude code leak was a perfect example. By with a very tiny package mistake, it can cause us the significant damage. The security gate in the release pipeline catches that if the release um, security security gate catches this problem in the release pipeline, that would have saved a lot. Source map stripping, security scanning, dependency auditing, those are things that can definitely be caught up in your CSD pipelines. Shift to sandbox agents by default. I've seen people installing OpenClaw on their own computer or on devices without, a proper sandboxing. This terrified me. I I feel that people need to be educated to not do that. Threat agents like privilege insiders, not trusted employees. The OpenClaw default of 0.0.18789 with zero authentication should never get shipped. Default to containers with no new privileges, tap drop or PMS, no execution, read only, root file systems, make the secure configuration of the easy configuration the easy configuration. Shift 3, supply chain provenance. Know what you are installing. Log the dependency. Automated scanning of every transitive dependency. Make sure the npm and the pip installs block. Make sure so you scan the software you downloaded using npm and pip. That technology exists widely in every project. Shift 4, behavior monitoring. This is like the big one. This is the big one for model safety. Watch what the models do, not just what they say. Mythos has 65% unfaithful chain of thought. The reasoning trace did not match the actions. We need runtime behavior analysis, not just output filterings, action monitorings. What fields did it access? What commands did it run? Does the behavior match the stated intent? Shift 5, identity verification. Early identity frictions. The first 30 to 90 days of a new employee should include hardware-bound attestation, live session verifications, and biometric challenges. Yes, it adds frictions, but 36 companies were infiltrated by synthetic data identities because it did not verify. The cost of friction is lower than the cost of infiltration. So those are the major shifts we can expect to see in the next while. And here's the thing. We are not starting from zero. We have an incredible advantage as builders. This is where this talk will shift from the little bit the negative side to the a little bit bright side. The same AI capability that create those threats also create the best defenses we have ever had. And defenders have a structural advantage. We understand the systems because we built them. This is alert triage times went from 45 minutes to under 2 minutes. This is not incremental improvement. This is a category change. 25% speed up in the most time critical part of the instance response. False positive revolutions. False positive rates dropped from the 60 to 80%, down from 60 to 80% down to under 10%. Previously, 65 alerts went investigated. Analysis were drawn in noses, but it's under 5% now. That means real threats are getting attention for the first time. But only 14 of the organization fully trust AI to autonomously block threats. There is still a human in the loop, and this is wise. We are building trust through demonstrated reliability, not blind faith. So new tools, AI-aware EDR, endpoint detections and response that understands AI-specific attack patterns, not just scanning malware files, monitoring agent behaviors, tool usage patterns, prompting injection attempts. We are building the immune systems for AI-powered infrastructures. Claude Agents is another example. So it's an open source. It's open source within the days of OpenClaw vulnerability. The community self-corrected. The speed of the responsibility. This is our advantage. So we have our tools. We have the advantage. So why do this instance keep happening? Because there is one question that nobody is asking. Let me call back noise animating this screen. 3 cases, 3 missing questions. Give it a moment to land. OpenClaw shipped with a default bind of 0.0.8 and zero authentications. 135,000 instances on the open internet. Nobody asked, what if nobody configures authentications? Claude code shipped with the .map files in the npm packages. 500 sounds of lines of source code exposed. Nobody asked, what if our source map leak? Klein published a compromised package. 400 developers affected in 8 hours. Nobody asked, what is the dependency get poisoned? The path, it is a common pattern. 3 different products, 3 different teams, 3 different failure modes, but the same root cause. Nobody asked what if question before shipping. we already do this for databases. What if the table has 10 millions of rows? We do it for APIs. What if the endpoint gets 10,000 requests per second? We just have not built the habit for AI system yet by asking similar questions. So I'm not asking you to slow down. I'm not asking you to stop building. I'm not asking you to stop using AI. And I'm just simply asking you to add one habit before every release, before every ships, ask what is the worst that could happen? One question that is the entire ask. And I want to end with why I'm genuinely deeply optimistic about where we are headed. This is a emotion part of the talk. I give this talk because I believe in the community, whether you write code, publish research, set policy, or are still learning. You are the ones who will shape how this technology evolves, not headlines, not just talks, but you. You're not facing an unsolvable crisis. We are facing engineering challenges at a new scale, and the solving engineering challenges at a new scale is what we do. It is what we have always done. From mainframes to the internet, to mobile, to cloud, every platform shift brought us new security challenges, and we figured out every single times. The reason will not stop, and it should not. The breakthrough we are seeing are real and significant, but we got to choose how we run this race. We got to choose whether speed and security on competitors or, or collaborators. I spent a month studying those security reports because I care about what we are building. Every finding was concerning, but every finding also pointing to a solution. That is the nature of an engineering problem. They have engineering solutions, and we have engineers. And on this note, I'd love to hear your thoughts. And yeah, let me this hope this wraps up the talk, and I'm here to hear your questions.
Yeah, thanks for the wonderful talk. Yeah, any questions?
Hi, Chris. Thanks for the presentation, and I think this is very timely. And I have a quick question. The I know that you said enough about how dangerous OpenClaw is, but
Yeah,
the fact that Jensen Wand announced NemoClaw, which is it's very welcoming and it's timely as well. It's already available, but I was someone who deployed OpenClaw early, and then I saw, hey, how dangerous it is, and then I say, well, I'm gonna not gonna let it use any of the real credentials. I basically have to set up a new accounts for it to use, and then I realize it doesn't really do anything if you don't give it real power. That's the
yeah,
same thing with NemoClaw. I looked at it, if NemoClaw is just like something just crippled OpenClaw every single capability with a predefined rule-based policy. So what I think it is that the rule-based policy has to change, has to
yeah,
adapt itself using an AI or syncing mode in order for it to adapt to the uh, the real world. So my question is that you think you feel that you're optimistic because hey, we can build, but I'm not as optimistic as you are though, because if much like 80% of the code, Anthropic says 80% of the code shipped are already written by bots. The fact that the map file gets leaked, it's very possible, first of all, the person in charge of the release doesn't even know the concept of the map file. And I did not know. I mean, I don't do hands-on deployment, but I understand why the map file is there so that you can pinpoint to the exact line of code when, you throw in there. But I don't think most people even knows that map file. In order for you to basically facilitate the debugging of the code, you have to provide every single line of code in there. So, that's something. It's going to just getting worse because most of code are written and released by bots now. And who's going to check on? You said, well, we're going to have human in the loop. First of all, like you said, the 27 seconds versus 48 hours, human just can't match the speed. And secondly, the amount of the lines of codes generated by AI is so humongous that just not enough power for human to look over. So what's your thought on that? I mean, like, two questions. The first is that the policy-based security system paradigm or policy-based security paradigm, I don't think it's useful anymore. And second is what we can do about that. And second question is that what do you do when AI generates way faster? And ho- if you say, well, I'm going to deploy more AI to look through the code, how can this even work? Because I think you see, I don't know if that capture is real. The Opus of 4.7 still have the 9.9 versus 9.11 problem. I mean, I'm shocked. I thought that problems was solved a long time ago, but there's always a outlier or long tail for any of the AI system to respond to the slop that it generates. I mean, I'm sorry, the code it can be uh, brilliant, but they're not as efficient as human written code. So these are two questions. Thank you.
Yeah. Yeah, those are really, the excellent questions. Uh, yeah, I think you point out the very challenging situation that and the brought out the very philosophical questions. Should we even trust the AI to guard ourselves from malicious AI? That is a very philosophical question. Because currently, we used to use the curiosity and our policy based approaches to defend ourselves. But as AI evolves, I the natural thought would be okay. So let's use AI to defend it, and let's use AI to help us. That's the natural thought. But I feel like, but deep in my mind, so I just feel that we shouldn't do that. We should just give everything to AI and let the AI to make decision for us. AI can do investigation, can help us and do analysis, and can automate a lot of things. But we still need to make a decision. I feel like more and more like so you should be treating AI in a way that we are treating people. And the one thing that it talks about is so the trust building. When we are dealing with the people, we mostly behave based on trust, and trust needs time and the interactions to build up. And it's not just the one-time things or one-time thing or one-time interaction. We build up the trust through collaboration, through through conversations, and then we know we can someone we can trust. And I feel that's the same thing. And we probably, I don't know, I don't have a good answer to be honest, but I feel that maybe we start with something very conservative, like giving AI very limited trust. Then we try and, so try and fail and see, what are the boundaries and how much we can trust it and what we have to keep in our hands. I don't think this will be so a single task or so we get it done and we can we can lay down and let it run. I feel this will be continuous and interactive process, and we gradually then therefore we can gradually build up something that we feel confident we feel confident and feel comfortable to collaborate with AI. Essentially, I think how to collaborate with the AI will be the most pressing task itself or question for every one of us in the next while. And I don't think we are ready yet, just because AI is evolving so fast. What we learned today may not be true in the future. Mythos as a deceptive behavior as a good example. So I feel, so that I can understand the previous generations of AI to some degree, but I'm to be honest, I'm really scared of Mythos. So that because it can cheat. It can this, but I, yeah, I think we'll figure out. I think we'll figure out as we move forward, and as we see more and more and do and more, and we'll figure it out. Sorry, I probably don't answer your
No,
questions,
it's good.
because
It's a
there are a
discussion.
lot of unknowns.
I understand. Did you get a chance to have hands-on experience with missiles? Because I mean, was it
No,
Microsoft during
no, I'm not on the team. So to my knowledge, there are other teams who so the testing, the benchmarking, but yeah, not my team. My team is more about the malware detection, the
I see.
traditional way.
Huh. I see. Well, thank you.
Yeah, no problem.
Uh, More questions? Yeah, actually, I just put a link, a blog in the chat. It's about when AI ready world's software. Who verifies it? I think you cover it somehow, but I don't know how for the software, the final solution, the ultimate solution, maybe the formal verification. But nowadays, those large language models, those AI code, I don't think they leverage this enough yet. So, for example, yeah, I don't know, the detail of like Anthropic or Codex, how they do those things, but I'm I guess they have not fully used those kind of software verification to do the for the training. I think usually uh, when they train, they take several tests, and then if the tests are passed, then they think the program is correct. But in this way, uh, we cannot guarantee it's correct. So we have to verify it formally, so we know it's correct. But this correctness is actually related to the potential bugs or vulnerabilities. So yeah, I want to say I'm actually pretty pessimistic about the current technique, and I don't think the current large language model or AI coding language models, I don't think they leverage this verification enough. So, but it will be very costly. But sometimes the cost makes sense sometimes. It depends on what kind of applications. If the application doesn't care much, then that's okay. If the application does care about the correctness, even the correcting is okay. So and there may be bugs, there may be safety security issues. So, but the current language models, I don't think there will be lots of problems. On yeah, if they are writing code very fast, just like uh 20K lines of C compiler, but it's very hard for human beings to verify those. Yeah, I don't know. It's a comment or question, but I think you cover it somehow. But I don't know what's your opinion. But I'm pretty pessimistic. Okay.
Yeah, let's hope for the best.
Yeah. 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 I don't know. Yeah. Okay. Other more questions? Yeah, I don't know. I think all those people are Chinese people, right? I guess. Maybe I can stop the video now. Thanks for Chris. And if people want to chat in Mandarin a little bit, maybe we can do that. I'll stop the recording now. Yeah, thanks for Chris. Maybe.
Yeah.